Good morning. Welcome to Monday, our first day back in hybrid. So if you're in Group B, you're watching this today on Monday. If you're in Group A, you'll watch it on Tuesday or when you choose to do the work. Okay. So Group A is going to be working on an activity here in class. Group B, you'll be working on mutations. So what you guys are going to do. The other thing I guess I wanted to show you is I got some feedback from you guys on that form, and one thing that stood out to me is you wanted to kind of see ahead of time what was happening. Okay, and so what I'm going to do from now on is put the whole week's agendas onto this slide deck, and you'll be able to see and work ahead if you want. Okay, so I'll make the videos for Wednesday and then the video for Thursday, Friday ahead of time. So if you choose to work ahead, you could do so. So what you're working on today at home is this mutations worksheet. The other feedback that I got was kind of organizing things in terms of making sure that it was more easy to see. And remember that you don't need to do anything with Canvas. We're doing everything here on Classroom. But what you're going to do is I'm trying to name things by dates. So asynchronous will always be something you're working on at home. Synchronous will be something that we'll work on together. All right. So this is the worksheet for, this is what's happening on Monday or this is the asynchronous assignment. If you're Group B, it's Monday. If you're Group A, it's actually going to be on Wednesday because Tuesday you'll finish the activity that we're doing in class. So what it looks like, we talked about on, there's a couple of good videos. Again, you're going to use the codon chart. You'll first transcribe, which means you'll take the DNA to RNA. So T would bond to A. This would read A would bond to U, and C would bond to G. Okay, and then you would do the rest of it. Then you're going to transcribe it using the codon chart to get the amino acids. Remember, AUG is going to always code for methionine, so that one I already know. Then you have 3 mutated sequences. With each of the mutated sequences, you're going to decide what type of mutation it is. And how you're going to know that is from this information up here. So you'll decide if it's a substitution, that means that one nucleotide was just swapped out. If it's a frame shift, it's either been deleted or added. So there's either a missing one or an extra one at the end. And then you'll see what happens. Or chromosome mutations are when they actually exchange within a different chromosome or take off several of them. Based on what happens is what it does to the protein. So if it's a silent mutation, there's no change to the protein shape. It still can do its job. Missense is that it makes the protein, but the shape isn't right for it to really do its job. So the job will be modified. And then a nonsense mutation is when it doesn't make a protein that's workable in any way, shape, or form. And so it's either really too long or way too short, and so it can't do its job. So what you'll do is, this is our original protein, that amino acid sequence. You'll compare the mutated to the original. And based on what you find, you'll first decide what type of mutation it is. Is it a substitution or an insertion or deletion? And you'll highlight that. And then what you'll do is decide what happened to the amino acid sequence. Did it not change at all from the original? Was there one letter that changed? Did it stop too early? Did it never stop? Was there one that was added or deleted, etc.? Okay, or everything changed after the mutation. From there, then you'll just do the same thing with these other ones, and then there's a couple of questions here at the end to answer about mutations. And we will talk some more about mutations on Thursday and Friday in class. So have a great day when you're working on this, and I'll see you in the room.